Hello everybody and welcome back. Today we're going to be talking about inequalities. So this is the beginning of Unit 4, 4-1. So inequalities are kind of like equations, but instead of finding just one solution that makes an equation work, an inequality is going to have a bunch of solutions that make it work. So off the bat here, let's get going with defining an inequality. It's any math sentence that contains these symbols. So we're going to have less than, greater than, less than or equal to, or greater than or equal to. So with an inequality, these symbols show that, let's say we have x is greater than 0. If x was equal to 0, then that is the only thing that makes whatever number sentence we're dealing with work. But if x is greater than 0, that means 1 is a solution, 2 is a solution, 3 is a solution, 3.5 is a solution, 3.57 is a solution, etc. So there are infinite possibilities for solutions to inequalities. So we can have inequalities that are true, such as 3 is greater than 2. Well, that is true. -1 is greater than or equal to -1. Well, it's equal to itself, so that works too. We can have false inequalities, such as 3 is less than 2, which we know is not true, so that doesn't work, even though we wrote that it does. -1 is greater than or equal to 4, also not true. And we can have open inequalities, kind of like the example I gave over to the other side. So this is going to be one that has many, many solutions to it. Anything that is bigger than 2 will work as a solution for that. So when we are graphing inequalities, we want to pay close attention to the symbol that's being used, because if if we have a greater than or equal to or less than or equal to sign, such as right here, then we need to use a closed dot when we are graphing this thing. So for the example, x is less than or equal to -2, well, we want to create a closed dot on our graph, and everything that is less than -2 is going to work for this. So we want to draw an arrow showing all the solutions that work. Alright, and then for a less than or a greater than sign, such as here, we want to use an open dot, which means that the number that is being showed is not included in the solution set, but everything else is. So, up above we had -2. With a closed dot, that means -2 works for the answer. For this one here, when we have a open dot, that means everything to the right of this counts in our solution set, but -3 itself will not be included in our solutions. So 3.01 would work, -3.01, or never mind, sorry, that's to the left, which is less than. So -2.99 would work, -2.5 would work. Everything up until that -3 point is going to be counted in our solution set. So we're going to try graphing a couple here. So x is equal to -4. Well, that's not saying anything is bigger than or less than anything else. So all we have to do is draw a dot on our number line here, closed dot, because 4 is the only solution included. So if we have x is greater than 0, well, then we need to take a look at our sign here. It does not have a line under it, so we're not including 0 in our solution. So that means we need an open dot. And everything to the right of that is going to work. Everything that is bigger than 0 will be counted in our solution. And then finally, we have y is less than or equal to -2. So once again, we want to take a look at our symbol that's being used. We have less than or equal to. So we're going to create a closed dot because of that equal to sign on there. And we want everything that is smaller than -2 or equal to it. So the closed dot shows the equalness, and then our arrow to the left will show everything that is smaller than -2 that will work for our solution. Alrighty, so next we want to be able to take a look at graphs and create an inequality based on what we see in the graph. So here we have a closed dot, which means we're going to have the bar underneath our less than or greater than sign. So we have a closed dot at -1, and it's showing us solutions that are all bigger than -1. So we are going to say x is greater than, and it's a closed dot, so don't forget your equal to sign underneath of it, and -1. X is bigger than or equal to -1, and that is what is being shown by this graph here. Alrighty, so next we have an open dot at -4. So remember, open dot does not include the equal sign underneath. So we're going to start with our variable, and it looks like everything that is smaller than -4 is going to work. So we are going to use a less than symbol with no equal sign underneath because it's an open dot, and everything that is smaller than -4 is going to work for that. So that's our inequality based on that graph there. So, and then we're going to run into questions like circle all the numbers that could be x in the following inequality. So this is telling us that x is bigger than or equal to -2. So we want to find all the things that are bigger than or equal to -2. Well, -3 is smaller than -2, so we can't include that. 4 is definitely bigger than -2, so we're going to circle that guy. 0 is bigger than -2, so we'll give that a circle. -2 is not greater than -2, but we do have that equal sign underneath it there, so -2 is equal to -2, so we can use it too. And we're just fishing through to find everything that is bigger than -2. So the only ones we have that aren't here are -3, -31, and -101. Those are all less than -2. So we will not be circling them. All right, so that's it for today. Nice and quick and simple. Excuse me, graphing simple inequalities here. So our independent practice starts on this note page, so don't forget questions 1 and 2 here when you are working on your assignment. And I will be back tomorrow with where we will start to solve inequalities here, which is going to be a lot like solving equations, so don't get too worried about solving that. Pretty easy there. So once again, don't forget 1 and 2 on your assignment here, and we will be talking again tomorrow about solving one-step inequalities. Thanks, and I'll talk to you later.